Okay, welcome everyone, and welcome to this drop-in session. So we'll be doing some of the learners will be presenting their their visualizations on how they have used their visualizations to answer some of their business questions. So it will be an interesting session. So I'll start with Lionel. So Lionel has a few presentations on some of his data sets. So Lionel, you can share your screen and take over. Yep. Thank you. Let me see if I've given you access to be able to share your screen. Make a presenter. Yep. And also make a presenter. Okay. Okay, yes, we're able to see your screen, Lionel. So can you
Okay.
maximize if you go to your bottom right, can you maximize the presentation? Yes.
Okay. Am I audible enough?
Yes, you are audible.
Okay. Good evening, everyone.
Yeah, good evening.
So my first data set will be unveiling house pricing market dynamics through data analytics. The aim of this project is to leverage data set containing various attributes of houses to analyze, predict, and provide actionable insights on house prices. The analysis and visualizations we are going to look at include bar charts, box plots, line graph, and trend analysis. Now, when you get the data, you have to observe what the data is about. The data contain 1,460 rows with 21 columns. It was mostly made up of two data types. These were object and integers. And in order to extract useful insights, we needed to clean the data. So to clean the data, I had to build a data frame from the data. Now, in the data cleaning process, we need to follow the steps provided here, which are identifying and handling inconsistencies, checking and handling missing values, identifying and handling duplicate values, detecting and handling outliers, detecting and handling correlated values, and finally performing some feature engineering. Now, after cleaning the data, we need to establish a data pipeline that will help us with the finalized clean data. After cleaning my data consisted of 1,457 rows and 21 columns. This is a snapshot of what my data looked like. So the first business question I was answering was, how does the zonal classification affect house pricing?
I'm sorry, Lionel. Your screen is frozen, so we can see only the the third slide, which has the observations, the data cleaning process, and the post cleaning. So we cannot see. Um, it's I think it's frozen.
Okay, let me.
Yeah, we can see your mouse. So
Can you
can you
see
go?
a snapshot of my data?
Yeah, but we can see it on the left side and not on the main side. So now what we are seeing, the main screen we are seeing is just the observations, the data cleaning steps, and the post cleaning. You can stop sharing and
Okay, because
reshare.
right now I'm on the snapshot and
Yes. just stop sharing
And
and
share
we,
again.
yes, and share
Okay.
again. It happens sometimes. Okay, perfect. So we can
Is it
see you.
visible now?
Yes, visible. It's visible. So we can see a snapshot of your data.
Okay. Yes, so this is snapshot of my data
Yep.
containing the zoning, location area, street, land contour, utilities, house style, year built, and total surface of basement. So the first business question that I answered was, how does zonal classification affect house pricing? Now, for the context of understanding, I make sure to um, give the definition of the abbreviations below the zonal classification, where RL is for residential low density, CL is commercial, RH is residential high density, RM is residential medium density, and FV is floating village
It,
residential.
it's still frozen. Is it only at my end? It's frozen again.
Hold on, let me see. Oh, which screen is visible? What can you see now?
We can see just the snapshot of your data.
Okay, okay, let me
Okay, so
stop again.
yeah, stop again. This time, do not maximize your presentation. So do not click on that.
Station.
Yes, on the button
Okay,
which
okay,
will, yes, let's not maximize the presentation. Let's just keep it. Yep.
okay. Can you see
Yeah, yes, we can see.
the box
So
plot now?
yes, try to go to the next slide. Let me see.
Hold on.
Okay,
Can you see the
yes.
next slide?
Yes, we can see the next slide. Okay, so let's not maximize. Let's just keep it like this. Okay.
Okay, I
Yeah.
hope you can still see what is written
Yes.
on the slides.
Yes, we can see everything is very clear.
Okay, so I will come back again. The first business question was, how does zonal classification affect house pricing?
Yep.
Where on the y-axis you have the house price, and on the x-axis you have the zonal classification, and below it is the reference for every zonal classification.
Yep.
So we can observe that um, the minimum value, the minimum price in zone FV is greater than or equal to the maximum price in zone C.
Yep.
This is zone C and this is zone FV. So where the minimum price starts for zone FV is where the maximum price of zone C starts. We can also see that in zone C, all the higher has the highest stability and the least variability, which means that the spread between the minimum and the maximum values in zone C is lesser compared or least compared to the other zones, which means that it is more stable to find a suitable house price in zone C compared to any other zone. We can also see that the distribution in zone RM is almost similar to the distribution in zone RH. And lastly, we can see that the variability in RL is very large, which means that it is more unpredictable. It is the most unpredictable zone among all the other zones, as the minimum and maximum prices have a very large gap.
Perfect. Perfect.
The second business question was, which neighborhoods or zone have the highest average house price? So based on this bar chart of average house price versus zonal occupation, we can see that the highest house price is the floating village or FV. It has an average price of above 200,000, followed by the residential low density, who has an average price of around 170,000, followed by the RH, who has an average price above 125,000, followed by RM, who has an average price around 124,000, and the list is the CO zone, who has an average price of 75,000. My third business question was which housing types are more popular among the buyers in different zones. So I made a bar plot, but in a stack form where each stack represents the housing style. So it's a combination of number of houses, zone category, and the housing style. So each color represents a housing style in each zone. So you can see that in the RS zone where most houses are being bought. In the blue zone, we have the 1.5 finished houses. In the yellow zone, we have the 1.5 unfinished. And in the green zone, which shows that it has the most bought houses, which are one-story houses, followed by the red zone of 2.5, followed by the 2.5 on fund, and then the second highest bought zone is the brown zone of two-story building. Then we have the the S foyer, and we have the S level. My fourth business question was, how do seasonal trends affect house prices? So here's the average sale price per month. Here are the months of the year from January to December represented in 1 to 12. So we can observe that there's a trend of increase in price from January to February, then a dip down in the price from February to March. Then you can see an up and down movement between the month of March to the month of October, and then we can observe a spike in price from the month of October to the month of December, which could be due to holiday season and promoters to give discounted prices for the houses, which may result in an increase in price over time. Um, what's the fifth? The fifth business question was, how does price vary by the year the houses were built? Now this plot has an issue which needs to be resolved later, so I think we are going to skip this because, as you can see, nothing here can give us a clear insight on the information we want to analyze. So we can skip these ones. Now we are moving towards what is the impact of houses renovations on the selling price. So I took into consideration different renovations, like the total rooms above ground was the first one. We also have the impact of kitchen above ground. Then we had the impact of fireplaces. Then we have the impact of full bedrooms, the impact of number of garages, and the impact of total surface area of sale. Now, from my investor's mindset, I decided to make a bar plot to see which of these renovations will bring a better return on your investment if you are to get into the market at a certain time, make a renovation, and to see your expected return. So based on that, this is the average return on investment for different types of home improvements. So you can observe that basement has the highest return on investment of up almost about 70% return on investment, followed by garage, followed by full bath, followed by fireplace, followed by kitchen above ground, and lastly, total rooms above the ground. So this is where I ended on the house price data set.
Okay. And before you go to will you present the other data set?
The other data set, the stress level one.
Yeah, do you want to present that as well?
Yes, I have something on
Okay.
it, even though it's not finished, but I have something on it.
Okay, so before we go there, let me just jump in to give some comments about what you have presented. So again, very good job, Lionel. So this is really good, and this is what data analysis is all about, right? So it's all about trying to extract insights from the data. And a lot of people would like the last plot where Lionel presents his return of investment. That was not a feature in the data set. So there was no feature in the data set called return on investment. But with Lionel's expertise in the domain and Lionel's research, so Lionel did some research about real estate and how to calculate the return of investment of different features in his data. So he created a formula, which is why we learned programming, right? Because without programming, you will not be able to create a formula. And I really wish, Lionel, next time I would really like you to add you just take a screenshot of your formula and add to
Okay.
and yes and add to your report. Sometimes it's very good because it doesn't only show that you have done the visualizations, because others can also do these visualizations using Excel or other visualization tools. So there are many visualization tools out there, things like Power BI, Tableau. But you adding the code there tells the employer or your stakeholder the amount of programming knowledge and I was amazed that Lionel created like a list. So he used all the fundamental aspects of Python which we have learned. So he created a list, created like a dictionary, added things, used a for loop to iterate through the list of his features to calculate the return of investment, which is very good, because sometimes when you create that formula, what happens is, yes, you have shown us the return of investment. It's amazing. So what that return of investment means is the basement has, if you have a house with a basement, you have a higher chance of making selling your house more expensive or making more money, and so on and so forth. But what happens is when you show us that code, others can criticize or critique your formula for calculating the return of investment. So it's not just about the results, but it's also to get feedback, right? So when you show like a
Yes, sir.
stakeholder that formula, the stakeholder will be like, no, I don't think this is the best way to calculate return of investment. Can we add this parameter? Can we add this parameter? And so on and so forth. So the people obviously understand what you mean by return of investment, the formula which you used. So that's the major comment I have on this visualization. If you go up a little bit, Lionel, to where you had a problem, where you had a problem with the line graph.
Yeah, hold on. I think this one, yes.
Yes, down. The second, go down again. Yes. So I really insisted. So Lionel had presented this problem to me a few days ago, and I really insisted that Lionel adds this problem in his report. The main reason why I insisted is because as a data analyst, everything is not always perfect. As you have seen, Lionel faced issues. So he tried to create a line graph to show the trend of average sale price in relation to the year in which the houses were built. But he had an issue in his code, and I would have a session with him to resolve that issue. But this shows the reality, and sometimes as when you're presenting to stakeholders, they are not only interested in they want to understand your mindset, they want to understand your day-to-day activity. So when you show challenges and tell them how you intend to resolve these challenges, they know that you are actually you have actually worked on the project, right? Because no project, you can't tell me you work on a project, you have no challenges, everything went smoothly, you solved all your business questions. And even there are some business questions which by the end of this, maybe Lionel will not be able to answer. Maybe, and he will give his reasons, right? Maybe there's not enough data for it. Maybe there's no column that can be used to answer that particular data. But it's always good to show challenges and issues faced during your analysis when you're presenting to stakeholders to show that you face some issues. This is what you think is the root cause of this issue, and you intend to resolve the issue later on. So that's it. Thank you, Lionel. Let's move on to the stress level. So you can take over again and move to the stress level data set.
Okay. So my project title for the stress level was investigating the effects of living conditions on mental health and stress level. So this project seeks to understand the impact of living condition on students' mental health by analyzing data on living conditions, safety, and mental health history. The study aims to identify various aspects of living environments contribute to mental health outcomes and suggest ways to improve for better mental well-being. So this is about the similar to what I explained in the first data set. The only difference is that this data set consisted of 1,100 rows and 21 columns, and after cleaning, it still had 1,100 rows and 25 columns. And they were all integers. Correct this. Okay. So this is a snapshot of the data set for the stress level. So my first business question was, how does anxiety level affect stress level over time? So with the line graph plotted here, you can see that over the period of time, anxiety level generates a spike in this level of stress. So over time, the more anxiety you feel, the more stress a student may experience. The second business question was, how does extracurricular activities impact stress level? Now we can observe that students with zero extracurricular activities have a higher stress level than a student with one extracurricular activity and a student with two extracurricular activity. Now, when a student goes above three extracurricular activities, his stress level increases. So it would be recommended that students do not go above three extracurricular activities in order to maintain or reduce their levels of stress. My next business question was, how does academic performance correlate with anxiety level? Now, this is a regression plot that shows the relationship between academic performance and anxiety level. You can see that it's a regressing line, meaning that academic performance decreases with an increase in the level of anxiety. So for a student to have an optimal academic performance, his anxiety level needs to be closer to zero. The next business question was, how does academic performance correlate with depression, which is similar to the one above. Then the next question, which is my last question, I think, for now, is sleep level and stress level, which is also a regressing line. So, Prof, you can take over from here
Okay.
because this is where my questions end for now.
Okay. Okay. So Lionel, just going up, if you go up to the first inside of the stress level, yeah. So the first thing about this plot is, yes, so everything you've said is really good, is really good. And obviously it shows that you have actually gone through most of the material. But the first thing I would like to say about your business question in this plot is, for example, you've said, how does anxiety level affect stress level over time? So The graph you have shown doesn't show the time factor.
Time.
Yes.
Yes.
So
Okay.
you see there is no axis of time, right? So the
Mm-hmm.
only so what your graph is showing is basically I wouldn't have said over time, or I wouldn't have used a line graph in this case. I would have
Okay.
What I would have done in your case would have been to either use a regression line.
Okay.
Yes, because what it shows is the stress, the anxiety level and the stress level. It's good. You could either use maybe so is the stress level compared. So you could use, yes, the scattered plot to show the regression, and what you would see, the line is already telling you that there is this increase in stress level as the anxiety level increases,
Yes.
but it's not a temporal, it's not a time factor. So I would actually change
Okay.
my business question to how does anxiety level affect stress level, right? Or what,
Okay.
or not
Okay.
even affect. I'll just say what is the relationship between anxiety level and stress level. Then you can use a scattered plot and a regression line. That will be much better, because a line graph, as I said, is mostly used for trend analysis. And when you're dealing with trends, you are mostly talking about the time factor, right? How things change over time. In
Yes.
this
Yes.
case, yes, in this case, there is no time factor. So we have to be a little bit careful about that. So that's my first comment. If you go to the second graph, which is really interesting. This graph is really interesting because, as you said, with this graph, you can actually make what we call prescriptive analytics. You can give recommendations. And what you will learn in our next course, we will learn how to test statistical analysis. We'll learn how to build hypothesis and test hypothesis. And I already see a very good hypothesis you can create here. The first hypothesis you want to create here is there is there a statistical difference between the average stress level in with two extracurricular activities compared to the average stress level first, is there a significant difference between the average stress level for zero extracurricular activity compared to three extracurricular activities? Because visually, what I can see is that it seems there is no, it seems there is, they are similar, right? It seems the average stress
Yes.
level for 0 and 3 are similar. So what if you find out that they are similar, and you find out that there's a statistical difference between the average stress level for two activities compared to three? You see the average stress level of two activities is a little bit lower than that compared to three, right?
Yes.
If you find out that it's different, it's statistically different, so the average stress level for two is statistically different from the average stress level of three, what your recommendation would be is you will, because you want people to have extracurricular activities, right? So the whole point is
Yes.
all schools always want their students to have extracurricular activities. But what now you will say is you will recommend students to have only one or two extracurricular activities and not three, because you see that there is a statistical difference that you see that three and the stress level when they have no extracurricular activity is the same as when they have three extracurricular activities. And you see
Mm-hmm.
that there is a massive difference or a significant difference between two and three. Because
Yes.
if you're saying the stress that people are having is the same as when they don't obtain any extracurricular, when they have extracurricular activities or when they don't have extracurricular activity, if it's the same, everybody will be like, okay, then why should I even actually have extracurricular activities, right? I
Curricular
would,
activities.
yes, yes.
Yes.
But the school wants to propose extracurricular activities. So the school wants something where even if you have extracurricular activities, you will not have the same stress as when you don't have extracurricular activities. So their hypothesis, so write this down. Your hypothesis, you have two hypotheses to test. The first hypothesis will be the average stress level between 0 and 3 to find if 0 and 3 are the same, are statistically the same, right? If they are statistically the same, which I will predict because I'm seeing it in the plot, then you want to show that 2 is statistically different from 3. If you show that 2 is statistically different from 3, then you want to propose 1 or 2 and not 3, because 3 has the same,
3.
yes, has the same stress level as 0. Does that make sense?
Yes, it does.
Yes, yes. So this is a great way to do prescriptive analytics. So what are we combining? We are combining the insights we're getting from your visualization with hypothesis testing to
Hypothesis.
propose, yes, to propose an action or to propose a strategy. So we're saying, okay, if the average stress for 0 and 3 are the same and the average stress for 2 and 3 are different, therefore let's go for 2 and not 3, because 3 means it's the same as 0. So let's go for 2. So the school now propose that it's always good for students to have 1 or 2 extracurricular activities because they are sure that the stress level will still be statistically smaller than if they had no extracurricular activity. So this is a very important visualization. So going to the next visualization. So the other visual, if you go now to the next one, so let's go down to visualization 25. So slide 25, sorry. Hello? Hello, Lionel?
Yes, Prof, I can hear you.
Yes, can you go down to the next slide? Yes. So these slides and the following slides have show us something. It gives us some information. I like the fact that you experimented on the regression line. But the first thing that I see, so this for this business question, you are trying to answer how does academic performance correlate with anxiety level. The first thing I will notice in this plot is that there is no correlation.
Relation. Yeah.
Yeah, so when you as from what I said, so the first thing in the when you notice that there is no correlation, the first thing you do, you don't need to go further to plot the regression line, because the regression line, yes, because the regression line will not inform you, because the regression line is dependent on the fact that you observe a correlation or you observe a pattern in the data. But if you look at the data, there is no, if you ignore the regression line you have plotted, there is no format. So no, because what I said about patterns is you see the entire data moving in an upward trend or in a downward trend, but if you see the data is scattered everywhere in the
Everywhere.
plot. Yes. So there is no
Mhm.
relationship between academic performance and anxiety level. You understand? So what it means is
It-
students that have zero academic performance have shown similar anxiety levels as students that have one, and have shown similar anxiety levels as students that have an academic performance of 2, 3, 4, 5, and 6. So you see that it's spread throughout the entire data. And I will, if you after you had this regression line, if you would have calculated for what we called, you remember the correlation coefficient,
Yes.
if you compute, so I'll give you this task. So for the your next three plots, which I have already seen that they have no correlation
Cool.
between,
Yeah.
yes, if you calculate for the correlation coefficient, you will notice that the coefficient is close to zero. So that already tells you that there is no correlation. So when you already see that the correlation coefficient is very close to zero, there is no need for you to plot a regression line, because that regression line, you cannot actually interpret that regression line when the correlation coefficient is that low. It's close to zero, because actually there's no correlation between these two features. So what I would enable you to do is to remove that that regression line from your plots, keep the plots, and show that you wanted to find the performance, the relationship, if there was a relationship between academic performance and anxiety level. Keep that plot, but interpret what you have seen, right? So you have seen that there is no correlation between academic
Relation.
performance and anxiety level, as the data is spread throughout the database. So there is no upward trend of data or downward trend of data. So you do that for the other one. So it's still an answer to your business question, because your business question wanted to find if there's a relationship, but you have found that there is no relationship. So
There's no relationship.
keep the plots, but remove that regression line, because that regression line is confusing. It may give the wrong information, that there is actually a, a decreasing relationship, but obviously there is no relationship. You can also add the p-value to your report. So you if sorry the correlation coefficient to your report, to strengthen your decision or to strengthen your insights as well. Is that okay?
Yeah, it's okay, Prof.
Okay, okay. So thank you so much. And yes, so you already, the good thing is, by you just presenting this, we already have next steps. When we teach the hypothesis, you have, or you already know the next steps on where you will need to focus your attention in hypothesis. And you can even start looking at the hypothesis of, even though you didn't see any relationship between the academic performance 0 and 5 academic performance, you want to create a hypothesis where your hypothesis is that there is no relationship, there is no difference in anxiety level if students have a 0 performance or if their performance is 5, and you test that hypothesis and to actually confirm that actually when students have a performance of 0 or if they have a performance of 5, there is actually no difference in the anxiety level. So that is another good hypothesis for you to develop. So I've already seen another hypothesis. We had one in the previous plot. We have one in terms of academic performance, and you can create more hypotheses. So when we do the hypothesis part, you actually know where to focus your hypothesis execution on. So that's really good progress. Well done. And just do some of the